February 2013. The world's astronomers watched an asteroid sailing past our planet.
We've got a fairly big asteroid going past. It's getting very close.
Don't think that Valentine's Day will be your last full day on Earth. There's no reason to worry.
The problem was, they were looking the wrong way. You wait ages for one asteroid, then two come along together. And no one spotted the second space rock sneaking up behind on a collision course with planet Earth. Now scientists scramble to work out what happened.
The hairs stood up on the back of my neck.
Where did it come from?
As the meteor is moving very fast, so the shadow is swinging around.
What was it that hit our planet?
I want to get my hands on some of that meteorite in Russia.
The world is seeking to learn why we never saw this coming, and if it will happen again. "9 a.m. in the Siberian city of Chelyabinsk. Lessons were starting in schools. Offices filling with staff. The true story of Friday the 15th of February began here, with life in the city, and cameras that soon will record an extraordinary experience. At this point, no one on Earth had the faintest inkling of what was coming their way. It was bigger than a double-decker bus, careering towards us at 40,000 miles an hour. It was arriving without warning. At the Olympic Judo Training Center, Ivan Chetvakov was taking a class of young children through their warm-up exercises.
It was Friday morning, and the room was full of about 100 kids.
Across town, drivers were battling the city's notorious rush hour traffic. Like many others, Ruslan Safarov was filming with a dashboard camera, recording evidence in case of an accident. Such cameras are popular accessories on Russia's notoriously dangerous roads.
It was about 9 in the morning. I was driving my wife to work. You know, just not average day.
At 9:20, the space rock hit the atmosphere, still far too small to be seen by those who live in Chelyabinsk.
I was laying in bed. I had just hit my snooze bar on my iPhone to get a couple extra minutes of sleep and rolled over.
Until seconds later, when it appeared, literally out of the blue.
We were just here when the flash happened. It was over there, on the left.
Near its journey's end, the ice-cold asteroid had been transformed by intense compression of the air into a flaming meteor. Uniquely, some cameras, including Ruslan's, captured the moment the meteor appeared.
This light appeared in the sky. I saw it getting bigger and bigger.
With superheated air bursting into brilliant light, scientists call this a fireball. These images of its passage are not just beautiful, they are priceless to science. Rare data of a fireball's speed and direction. The briefest of lives, a mere 17 seconds, but a death brighter than the sun.
Then it became extremely bright. I had to turn away and close my eyes.
The flash was so intense that I was blinded for a moment. I couldn't see anything. I had to look away. I couldn't understand what was happening.
For the first time in history, the most stunning, violent beauty of a fireball's brief existence was recorded in its entirety.
I saw everyone running outside and staring up at the sky.
Bizarrely, the explosion produced not a sound and caused no damage. Where was the Big Bang?
Here, at this bus stop, there was a bunch of people filming the sky with their phones.
Over the next 2.5 minutes, thousands more pictures were taken as bystanders grabbed the nearest recording device to hand and filmed the beauty trail left behind.
I went to the window and I looked outside and I just saw this giant streak across the sky. I had never seen anything like that before in my life.
Then at 09:22, the missing Big Bang arrived. Curiosity turned to panic.
I stopped the car to see what was going on. Maybe some kind of war or something. It was very hard to figure out what was happening in all the confusion.
Explosion after explosion rocked the city. What caused this artillery barrage of sound?
I hear a roar and the windows started to smash. That was followed by this massive clap, an explosion.
The building was shaking. The lights in my apartment were shaking back and forth. You know, it blew the vent out of my wall and there was debris and dust all over the ground.
Thousands of windows had been shattered. Over 6,000 buildings damaged, many hundreds injured. The roof was peeled off a metalworking factory.
A lot of people here suffered from cuts on their feet. We all practice barefoot on our judo mats, and all windows blew right into the middle of the room. We basically had to walk on glass.
The silence after the fireball explosion lured people to their windows. Hundreds were cut by flying glass as they stood watching the sky.
You can see for yourself how many people we have here. So far we have received between 60 and 70 in total.
So, what did hit Chelyabinsk that day? Why was there a long delay between fireball explosion and the blast that injured close to 1,000 people? And what of the meteor itself? No obvious crater. In fact, no sign of the object at all.
I got in my car and I drove around my building because I thought for sure there was going to be something, you know, stuck into the side of it, but there was nothing there. I was very confused.
News of Russia's misfortunes spread around the world.
Good evening. A streak of light, terrifying sound, shattered windows.
It was incredible. I mean, it really was unbelievable. You know, the hairs stood up on the back of my neck, sort of thing, thinking, wow, this is a once in a century event.
Like an astronomical starting gun, the blast kicked off a race to uncover what had happened. At first, the scientists were just as confused as the rest of us, and rumours abounded.
The first few videos I saw were so unbelievable. I did think to myself, have these been faked? You know, is this a piece of space junk coming in?
But the hundreds of videos all proved to be genuine. They were to become unique evidence of the rarest of events, each filmed from a different angle, to make this the most comprehensively documented fireball ever.
Without all these webcam images, we would basically know that something had hit and gone bang. But with all of these images and movies, we can actually work out what was going on, which is much more interesting.
In the coming days, the films would be pored over in forensic detail. But pictures aren't enough. Science demands physical evidence. Pieces of the fireball, the biggest in living memory, had to be on the ground. And one young British astrophysicist was desperate to join in the hunt.
What I really want to find out in Russia is I want to get my hands on some of that meteorite. I want to have a look at it. I want to find out what it's made out of. I want to find out where it came from.
Elizabeth would be the first Western scientist on the scene, the vanguard of a worldwide effort to understand what the fireball was and where it came from. We're still being circled by 80 million more rocks that big. And we have little idea of when another fireball might strike. In the aftermath of the Chelyabinsk meteor strike, scientists scrambled to understand what happened. Where did the meteor come from? What was it made of? Why did it explode so violently? Most urgent of all, why didn't we know it was coming?
There's a couple of reasons why we didn't get any advance warning of this meteor arriving. One is the size. It's rather small, so because of that it reflects less light from the sun, which means it would appear much fainter. And the other reason is the direction it was coming from. It came in almost out of the sun, so therefore it's much harder to see.
It's like the old fighter pilots during the Second World War. If the enemy's coming out of the sun, you can't see it. You're blinded.
This remote region of Russia is 2 days' travel from London. But British astrophysicist Elizabeth Pearson had won the race to get there ahead of any other Western scientist. Her first mission? Finding a meteorite.
I'm an astrophysicist. This Russian meteorite is fascinating. Hopefully, somewhere, we've got a nice big lump of meteor.
It's a bit of a race against time to try and find these meteor fragments because we want to be absolutely sure that we're getting to them before they start to deteriorate, before they're being affected by the snow on the ground, by all the water. We want to make sure that we get them as quickly as possible so they're as fresh as possible.
In the wide open spaces where the meteor struck, local entrepreneurs had realized that space rocks could turn into rubles.
If you want to check out big fragments, there, down the road, there are boys. They have it packaged for sale.
Everyone started to search for fragments to sell, so we joined in.
And the competition was pouring into town. A science team from Moscow. A scientist vied with scientist at the crash site. Others watched from afar. Our YouTube world instantly uploaded hundreds of scientifically valuable images. Many captured because of Russia's addiction to car cams. Soaring insurance claims have led to a boom in dashboard cameras. Anything happening on a road gets caught on a camera. From plane crash to overturned lorries. Nothing, however, could compete with what those cameras caught next. Scientist Dr. Richard Greenwood has had a lifetime interest in astronomy, the perfect person to analyze meteor footage.
We've got a unique event taking place in an environment in which people have filmed it extensively. It's absolutely incredible. It's an absolute treasure trove for science. So we're going to look at a piece of footage which is probably unique because it shows the fireball from beginning to end.
What makes this so unusual is that the meteor was filmed by so many different people, from so many different viewpoints.
This is a chap driving to work. He's got his camera on, it's sunrise, and suddenly the fireball comes out of nowhere. It's probably about 70 kilometers up at this stage. First time that's ever been recorded. Absolutely fantastic. You can see it coming right down into the lower atmosphere. You can see the head of the fireball starting to develop there. And what we have next is an explosion as it penetrates into the denser part of the atmosphere.
Over the next few hours, Richard would find out what this type of remote analysis could uncover about the rock that struck in faraway Russia. Meanwhile, deep in the vaults of the Natural History Museum, Dr. Caroline Smith was also looking for clues. Down here, she has some very special samples from outer space.
Well, meteorites come in 3 different flavours: stones, stony irons, or irons. These 2 that I have here, these are called stony iron meteorites, and these are a mixture of rock and metal. Because they've got so much metal in them, they are much heavier than a normal rock from Earth. I mean, that's a good sort of 12, 15 kilograms. And this is an iron nickel meteorite, and it's heavy. This is about 3 times as heavy as the one that I've just shown you. And because it's very dense, it does put into context the type of damage that you can get from something of that size.
Back in Russia, the search was continuing for the all-important rocks that might offer real answers. The search area was vast, the temperatures sub-zero, and the clock was ticking. After days of traveling through Russia's snow-clad countryside, Elizabeth was determined to find her rock before it got buried forever.
We're really lucky as it hasn't snowed, because it's a hard enough task trying to find a tiny meteorite fragment in all of this. But also, if it snowed, then it filled in all of the holes that the meteorites left as they fell to Earth. And if we can't see those holes, then we're going to have a much, much harder time trying to find a meteor fragment.
Playing on home ground, the Russian team had a significant language advantage. Eyewitnesses could help with their search.
So, was it almost above your head?
It was right there above the buildings.
But Elizabeth was also recruiting local players who'd already spotted some holes in the snow.
If I wanted to find some myself, where should I go and where should I look?
Around the forest.
They said that a good place to look would be somewhere over there, over by those forests, so that's where I'm going to head out now.
In more comfortable London, Dr. Richard Greenwood hoped a frame-by-frame analysis would show what the meteor was made of, a vital step towards learning where it came from.
This is another fantastic piece of footage. There's the explosion, and you can see it's broken into 2 there, 2. What happens next? Now it's fragmented. Look at this, look. 1, 2, 3, 4, 5 pieces. Let's watch that piece there going. Look at that. shooting off in that direction. The fact that it's fragmented in such a violent way, it's very likely to be a stony meteorite.
If it is a mere stony meteorite, there could be worrying implications. Scientists may have underestimated how dangerous such rocks might be.
Up until now, we've tended to think, oh, they're quite benign and cuddly, if you like. If that stacks up once we've done some testing, then we're going to have to look at stony meteorites in a different light, because obviously, with the right size, they're capable of causing great destruction.
Back in the vaults of the Natural History Museum, Dr. Caroline Smith's expert knowledge of what meteorites are made of has been leading her towards the same stony meteorite conclusion. She knows what has happened to a lot of rocks that have fallen from space in recent years.
This is called the Barwell meteorite, and this one actually fell over Barwell in Leicestershire on Christmas Eve 1965. So it's one of the few UK meteorite falls that we have. It's a sort of concrete grey colour. It's got this rocky texture. It's quite sort of rubbly looking. One of the clues is that this is heating up to very, very hot temperatures, so hot that the rock actually turns into a gas. That's what gives the really bright glow that you see from the fireball. That is so powerful that actually smooths the surface of the rock. So you can see this one has got this sort of quite smooth texture. We also see what looks like thumbprints. In fact, I can actually put my thumb into this one here. And these, we think, form as this object is hurtling through the atmosphere. You actually get little vortices of air, and it actually scours the rock away. Many of the videos show little spirals actually within the smoke trail, so presumably this is the sort of thing, these vortices happening. You can imagine a sort of vortex of air coming off.
Reports were coming in of a giant hole punched through the ice of a Russian lake. But local scientists had failed to recover any meteorite chunks from the freezing cold water. So Elizabeth had to stick with her needle in a haystack search.
You're in snow that's about half a metre deep. You just sink right in, none of it's solid. And all the while you're trying to move through while still looking for all of these tiny holes. So it's definitely trying to make me work to find these meteorites.
Finding a piece of the rock is the only sure, fast way to find out what it is and where it came from.
Very, very fine, tiny hole in snow.
He's finally spotted one.
It says, yeah, you can see here.
The first glimpses of these scientifically priceless pieces that fell from space.
Here.
But there's no such good fortune for Elizabeth.
Any joy?
No luck there.
But finally, with help from the team, Elizabeth gets her prized possession.
There we have it. That is one meteorite. It's got that grey black colour, very distinctive of the sorts of meteorites that come down to Earth. There's probably thousands more hidden out here.
Now they were in a debris field. Meteorite hunting suddenly seemed simple.
Let's see, maybe we'll find another one.
The next step for Elizabeth was getting to a laboratory. What clues might a meteorite provide? Astrophysicist Elizabeth Pearson was in a race to find some answers. She had teamed up with local scientists to analyze fragments of the meteorite.
These are some of the pieces that we found.
To see what the sample is made of, it was cut, polished, and magnified 300,000 times under an electron microscope.
They're the first people to get up close and personal with these meteorites.
So being here at the moment is a really exciting time, and seeing firsthand how these meteorites look really, really up close. We're looking at the composition to try and work out what it's made for. The kind of things that we're looking for are lots of minerals, several of them that can only be made in space.
The images reveal that the object that fell to Earth was, indeed, a stony meteor.
We're actually finding out here on the ground right now that it's about 8 to 10% iron. It's the typical levels that you find in meteorites that fall to Earth. Most of them are chondrites, which looks like what we've got here.
At first, the results seem somewhat disappointing, offering no real explanation as to why it exploded in such a spectacular fashion. But, moments later, Elizabeth saw something extraordinary. The meteorite she was examining had tiny stress fractures running through the rock.
And on this particular rock that I've got here, you can also see some shock melting veins, which is this dark vein here. And so that's when it got hit by another asteroid as they got messed around by gravity.
What this meant is that the asteroid must have smashed into another rock in space. Probably what sent it to Earth, and also helping to explain why it broke into pieces.
The cracks added to the fragility of the asteroid, which is why it broke up. It shattered along those veins.
In the coldness of space, the asteroid stayed in one piece. But entering the Earth's atmosphere, it couldn't stand the pressure and the heat.
It glows white hot. And anything, when it's that hot, will start to undergo a lot of stress, a lot of strain, and it will start to break up. And that's what happened in this meteor. It's good news, actually, that this meteorite was so fragile. Because even though a lot of windows got blown out and people ended up in hospital, because it broke up so high in the atmosphere, because this meteor was so fragile, that means that the shock wave had time to dissipate.
So this time we were lucky. But what might have happened to Chelyabinsk if the meteor had caused a lower-level explosion? That's precisely what happened 100 years ago in the remote region of Tunguska.
Back in the early 20th century, we had a large lump of ice doing an airburst, exploding in the air over Siberia.
Interestingly, witnesses living many miles away from the scene of the blast reported that they felt heat radiating down from the sky, even though the explosion was miles above the surface.
And it flattened a forest the size of Wales.
Those ancient reports of the heat felt in Tunguska have been echoed by some witnesses to the modern-day Russian meteor strike, though scientists have doubted the claims. The disputed reports of heat felt on the ground, so many miles below the airburst, are of particular fascination to Dr. Richard Greenwood back in London. He's examining video testimony from residents who saw the explosion.
We started to feel warm. It was like summer had come.
It was so warm. I felt it on the back of my neck.
They're saying that they're feeling the heat from the fireball, and that's quite interesting because I think a lot of scientists would disclaim that, but a lot of people are reporting that, so I think that's another thing that needs to be taken seriously. Is the heat energy given out? Is it actually getting to the people on the ground? It's an open question, but it certainly needs looking at.
Richard's examination of the shockwave is also explaining another mystery of the meteor, the long gap between the flash of the explosion and the damaging blast.
People had no idea what was about to hit. So this is a lovely bit of footage. It's a normal day in the office, or that's what they think anyway. And then all of a sudden, her colleague gets thrown across the room at her. That's the power of an air blast. That explosion dumps a huge amount of energy into the atmosphere, and that causes a shock wave which spreads out from that point. So it's effectively an explosion in the atmosphere.
Light from the blast and the shockwave it produced travelled 15 miles downwards to the city, but the light was infinitely faster.
There's a huge delay between the time that you actually see the event and the time that it actually hits you. The vision is travelling at the speed of light, and the shockwave will be travelling at a much slower pace. There's a fantastic piece of footage because this shows you the aftermath. People are studying the trail here. It's what's left after the fireball's gone through, and they think it's all over. It is now. So what we've got here is basically the detonations, which took about 3 minutes to get here from the airburst.
Richard has another clue to go on. The shockwave was so powerful that it was recorded around the world by sensors set to identify the blast of nuclear weapons.
Let's just have a quick look at what they recorded. So there you can see the trace, and here, look at this. And in fact, the energy released by that airburst was 30 times the energy of the bomb that was dropped on Hiroshima. Absolutely enormous amount of energy.
After analysing the footage, Richard believes that the anecdotal reports about a blast of heat could be true.
It's got to be remembered that there's a lot of energy being given out here, so I think there is a chance that they actually are feeling something genuine.
In Sherlock Holmes detective mode, Elizabeth investigated who most felt the heat. A clue to ground zero, right under the blast.
I just had a word with some of the locals, and they said that when the initial blast came that they felt a wave of heat coming off of it. And at first scientists thought this probably was just a psychological effect, but actually now that we've worked out some of the numbers, we realise that the surface of the meteorite was probably about as hot as the surface of the sun, and that means that you probably were going to feel a wave of heat coming off it.
She used the evidence of where the heat was highest to confirm she was at ground zero, and checked her theory with recently arrived American scientist Mark Bosler.
All right, so Chelyabinsk is here.
And we are on this diagonal road right
So we're
here.
somewhere around here?
Yeah.
So we're nearly directly under the
We're
explosion?
directly under the explosion.
What?
It's 15 miles up.
Yeah.
It was another huge clue to where the meteor came from.
We're standing directly under the spot where that meteorite probably first exploded.
Elizabeth knew that this knowledge could now be added to another key piece of evidence revealing the meteor's trajectory. The shadows on the videos.
They had a position at one point where they knew the meteor was overhead. The analogy here is with a sundial. In this case, the source of the light is the meteor. It's casting a shadow, and as the meteor is moving very fast, so the shadow is swinging around. You can actually use the angle and the length of the shadow to define a unique direction towards the fireball at any one particular time.
Incredibly, scientists have used the length of shadows cast by the meteor and the time the footage was taken to track its orbit in space. And here it is.
There's a meteoroid, there's Earth and Mars. You can see here that it crosses the orbit of Mars, but Mars is nowhere near that, so there's no problem there. It's starting to approach Earth, and then finally it impacts.
Once you know the orbit, you can trace it back in time.
They've backtracked it, and they've been able to work out an orbit for the body within the solar system.
And so finally, the groundbreaking work done by Elizabeth and science teams around the world found the meteor's origins in the asteroid belt between Mars and Jupiter.
We've got a crime scene. We've got a bullet, the meteor. If the asteroid belt is the gun, we have potentially a large problem. That's a gun with an awful lot of ammunition in it.
The asteroid belt is a densely packed repository of space debris left over after the formation of the solar system. Gravity traps the rocks together in an aimless mass until something gives them a chance to break free.
Two things can happen. As Jupiter goes around, it's the biggest planet with the strongest gravity. It stirs some of them our way, which is not good news. Or they can collide. One of these asteroids coming in from space following its own orbit can actually then cross our path. It's like a huge game of interplanetary billiards. These things are moving in their own paths. We can't blame the asteroid, it's just doing its own thing.
Of the big asteroids that we know of, we know their orbits. We can predict where they're going to go. We're happy that none of them are going to hit us. It's the ones which haven't ever got particularly close to the Earth but might start drifting close in the next 50, 100 years that we need to be concerned about.
With 1,000 potential extinction events queuing up to take a pot shot at us, is there anything we can do to dodge the bullet? Sometimes meteors hit our planet. Really big meteors.
Meteor Crater was formed about 50,000 years ago when an iron meteorite, about 2 or 3 times larger than the Chelyabinsk meteorite, slammed into the rock here with most of its cosmic speed still intact at about 40,000 miles per hour. The energy released in that impact was something on the order of 10 megatons of TNT equivalent. And it's that energy that was responsible for excavating this enormous hole in the ground and spewing that rock into the desert below.
Impressive though it is, it's nothing compared to the battering our planet has taken in the past. One vast asteroid hit the young Earth so hard, it created our moon. Multiple extinction events even before a meteor helped kill off the dinosaurs. In fact, meteors are raining down all the time.
That is the 100 tons of material hitting the Earth every day from space. So most meteors probably actually hit the atmosphere this kind of size, so they're quite a decent sized chunk of rock. By the time they're falling through the atmosphere though, they get destroyed and they actually end up landing as dust. And of course, we don't really get to notice that at all.
Every shooting star in the night sky is a meteor turned into space dust by the atmosphere, almost unnoticed, most of the time.
The Russian meteor wasn't a particularly large asteroid, but of course it was travelling at many thousands of miles per hour, which made its impact so much more intense.
Although we didn't see it coming, at least we now know where it came from.
This meteorite almost definitely originated from the asteroid belt between Jupiter and Mars. At some point in the past, it got knocked out of that orbit and sent on a collision course with Earth.
The problem is, there are plenty more where that one came from. The man charged with stopping them is former Apollo 9 astronaut Rusty Schweiker. He knows there are asteroids out there that could destroy us all.
By far the highest priority is you've got to find them. If you can't find them, there's no way you can protect yourself from them. So early warning, you track them and you plot their orbits, and by plotting their orbits, you can then discover by projecting those orbits 100 years into the future whether they will hit the Earth.
In fact, scientists have already been able to track asteroids with some success.
There it is.
On the same day as the Russian meteor, another asteroid called DA-14 flew between Earth and Moon. We've been tracking that one for more than a year.
To give you an idea of how close it actually came, here we've got an Earth, and for comparison, this would be roughly the size of the Moon. So if we just put the Earth down there for the moment, then we take the Moon would actually be a long way over here. In fact, much farther than this, but we'll just put it down here for the moment. And just to illustrate the point, the asteroid actually came far, far closer than the Moon to the Earth. In fact, it's about this far from the Earth on this scale, which is actually closer than the satellites that you watch your TV signals on, which would be sort of this distance from the Earth. So it's inside that ring of satellites.
About 27,000 kilometres up, which sounds like a long way, but compared to something like the Moon, it's really close.
It squeaked past safely. A successful prediction, but a hollow victory. We actually only discovered DA-14 when it last made a close visit, and it was only spotted when it had already flown past.
DA-14 has an orbit very similar to the Earth, so it's going to come close past us again. So the better we can track, the better we can predict what danger it'll be in the future.
So how do you track an asteroid? And how do we know if others could be engaged in a deadly pas de deux with the Earth?
The most efficient way to discover these near-Earth asteroids would be to have an infrared telescope in space, because these objects are dark and they radiate strongly in the infrared wavelengths.
Space veteran Rusty Schweikart wants to launch a space telescope called Sentinel. Clear of Earth's atmosphere and packed with infrared sensors, it would allow us to detect asteroids far earlier and with greater accuracy.
Sentinel will discover something on the order of 50% of the sort of city buster objects, and it will discover close to 100% of objects that are about 140 meters in diameter.
The biggest question: how do you stop them?
If we find a big asteroid coming towards us, the obvious thing to do is blow it up. But that's actually a surprisingly bad idea, because all the bits still hit you.
You're going to get a shower of fragments, and then the Earth will be hit basically by a shotgun rather than a rifle bullet.
You can try blowing up a large nuclear bomb next to your asteroid, which, because you're in space, doesn't produce a shockwave, so you don't blow the asteroid apart. You heat one side of it, and that side will get so hot it could vaporise just the surface. It turns that side into a crude rocket. But even that could break apart some asteroids.
Another way of deflecting an asteroid is simply to use the sun's light, because sunlight has a pressure, it pushes on things in space. An asteroid is quite dark, so it's absorbing the sun's light. Now, if you paintballed the asteroid with white paint, then that reflects the light.
And that very gently pushes it and nudges it and changes its orbit just enough that it misses.
The theories are all untested and may not be practical. Rusty Schweikart thinks he has a solution using existing technology.
I fly up to it with a small spacecraft and stay there and just hover in front of it. You're going to very slowly, using gravity as a tow rope, pull the asteroid in the direction it's moving, increasing its speed very slightly. And I end up with a precision adjustment to its orbit.
While some scientists imagine ways of stopping asteroid strikes, others are more interested in learning from them. Some believe they could even explain why we are here.
People see asteroids and meteorites as sort of bringers of doom and death and destruction. But the crucial thing to remember is that actually meteorites, many of us think, actually brought life to Earth. So what we think is that the early Earth could well have been seeded with the chemical building blocks you need for life to start. And we're finding so many of these amazing organic molecules that that's looking an increasingly likely scenario.
Other experts see asteroids as the perfect way to travel.
The idea is you'll take an asteroid, you'd hollow it out so you'd live inside. So you've got a purpose-built spaceship, you're protected from space. You also have the raw materials, you'd have the water and the carbon compounds that you could then stick a motor on the outside and some kind of rocket engine. You could power that using the water, you can split that into hydrogen and oxygen, use that to power your rockets. So an asteroid could become a self-contained spaceship sending a colony of astronauts beyond our own solar system.
For now, asteroids, rather than supporting life, are far more likely to take it away. As Elizabeth prepared to leave Russia, she was more aware than ever of the scale of the threat.
Current estimates put the size of the asteroid at around 15 to 17 metres, which is about the size of this building to give you a sense of scale. The actual asteroid probably weighed around about 10,000 tonnes. This huge lump of rock was coming in towards the Earth at around 44,000 miles an hour. So you can imagine how much damage it possibly could have done.
The Russian meteor really brings home that the Earth is quite a vulnerable planet sailing through space.
We absolutely could be wiped out by an asteroid. There are thousands of pieces of rock flying around the solar system.
We're overdue for a giant meteor strike. Chances are there is going to be one at some point in the future.
There is absolutely the potential that at some point in the future the Earth will be hit, which would wipe out humankind.
The bigger it is, the bigger the punch is going to whack the Earth with.
And if something like that happens again, we are wiped out.
Right now, to be honest with you, we're driving around the solar system without any insurance.
Next Sunday at 8, we look into Britain's greatest prehistorical mystery, an archaeological dig that delves into the secrets of the Stonehenge skeletons. Next night, though, a bit of Hollywood glamour and a holiday Johnny Depp will never forget. The network premiere of The Tourist is on 4.